explain to you how we did activity number 1. Well, in the first faucet in which we filled our 1-liter bottle, we measured that the diameter of the faucet was 1 centimeter and the radius was 0.5 centimeters. The timing it took us to fill the bottle, it was 11.65 seconds. So then the activity asked us to convert 1 liter to cubic meters, and the result is 0.001 cubic meters. Also, we converted our diameter to meters so we can have like equal measurement signs. I don't know how to say it. So the radio, it is actually 0.005 meters. And that's what we need to calculate our area for the circle, which is like the key of the faucet. So for the area, we need this formula, which is P multiplied by radius square, which gives us 0.0000785 meters square. And this is what we need to calculate the velocity. But first of all, we need to calculate the flow rate. The flow rate formula is volume divided by timing. So we got both, and the result it gives us, dividing them, it's 0.0008584 cubic meters over s, which is seconds. And with this, we can now go on to calculate the velocity, which is what the problem actually asks us to calculate the speed. The formula we used in here is the Q, which means the flow rate, volume flow rate, over the area, like divided by the area. We divided these both terms, and we got a result which is 1.0924 meters over seconds. Next up, we reunited the data from the second faucet. We measured the diameter and we counted the time. So we converted, as well as in the first faucet, the centimeters to meters. So it leaves us with a diameter of 0.017 meters, and with a radius of 0.0085 meters. Well, to calculate the area, we use the same formula as always, and the result it gives us is 0.00022 square meters. We're going to make the exact same thing as we did in the first faucet, which is, first of all, calculate the volume flow rate so we can calculate our speed. So we divided the volume with the timing, and our result is 0.00088 cubic meters over seconds. So now we can go on to calculate the speed, which is 0.3919 meters over seconds. Now we went on this next step, which is to calculate pressure difference. And for this we used Bernoulli's formula, which is pressure 1 plus density multiplied by gravity multiplied by height plus half of density multiplied by speed or velocity square equals to pressure 2 plus density multiplied by gravity multiplied by height number 2 plus half of density multiplied by velocity number 2 square. Well, as you can see, we already had all of the data asked in here, so it was way more easy to just like add and multiply and divide and everything. So we have our pressure number 1, which is 2,943 pascals plus, and we have like a parenthesis in here because first of all we need to like multiply all of these terms, which are the height of the first faucet, the gravity, and the density. We multiplied all of this and we separated them into here, but we're going to explain that later, because then we went on to separate this, like to resolve this actually. So I have here the velocity, and we like multiplied it by square v, then multiply it by 1,000, which is the density, and we divide it by 2. Then we go on the second faucet pressure, and we do exactly the same thing but with the other data. Here we like reunited the data with the results. So in here we stay with the 2,943 pascals. Then the result of this multiplication was exactly the same number. Then we add the result of this multiplication divided by 2, which is 597.76 pascals. Then we equal it to the results it gave us the next equation. We have the pressure number 2 added by the result of this multiplication, which is exactly the same number, and we add it with the result of this multiplication divided by 2. So we have all of these results, and we like start to add them up, and there you go. So the pressure, according to Bernoulli's principle, in the first faucet it would be 6,483.76 pascals, and the pressure in the faucet number 2 it would be 1,548.292 pascals. So the difference between these two pressures, these two faucets, it's this huge number, which is 4,935.468 pascals.